Okay, these are problems 10, 11, 12, and 13 on test review number 4. And I want to make a distinction between factors or factored form and then the standard form, or sometimes, as mostly the directions would be, give the result in a simplified form, but standard form, simplified would be the same. These two examples are factors. In other words, 9 times this whole expression, these are factors. Just like 9 times, if it were just 5, 9 times 5 equals 45, and 9 and 5 are factors of 45. Well, it just so happens that this 5 is expanded into an expression, but the two together are still factors. The 9, and then what's in the parentheses is the other factor. Same here, the negative 3 is a factor, and this inside is another factor. In this situation, they want you to not have it in factored form, but in standard form or simplified form. Another way to say that is some people say, oh, get rid of parentheses. Well, that seems very vague. So obviously, I'm sure you're way ahead of me. You know that if you did the distributive property, 9 times each of the expressions inside the parentheses will then simplify the expression. So 9 times 5 is 45. 45x. And that is still plus, because you have a plus here and a plus here, so 9 times 3 is 27. So now you have simplified it or put it in standard form. It's no longer in factor form. So then here you do the same thing, the negative 3 times the first term and the negative 3 times the second term. In this situation, however, you have a minus 4. So look at it as an entire negative 4 as one unit. That's the fastest and easiest way to deal with it. Okay, so negative 3 times the 9 is then negative 27, and the x is still there, nothing happened to it. Instead of saying minus, we're going to say negative 3 times minus 4 gives you a plus 12. That just cuts to the chase. Okay. So then down here what we have is these expressions are now in standard form down here. And we have to put it to the factored form. They want factors. So we have to think, well, what times what? It's going to look something like this in the end. You'll have a number or some expression outside of another expression in parentheses. In this situation, we have to think, what can I divide this term by and this term by to give me whole numbers, if I can get whole numbers. Sometimes you can't, and it's already done. So only one of them has a y, so don't worry about dividing any letters. But we see that 18 and 90 could probably have common factors between them. They have a common factor of 2. They have a common factor of 9. But they also have, and I can show you by the calculator, a common factor of 18, because a 90 divided by 18 equals 5. So 5 times 18 is 90. So that means we can divide each term by 18. You want to try to divide each term by the largest number that you can. So when we reduce, 18 over 18 becomes 1, so it's 1y plus 90 over 18, and we saw in the calculator 18 times 5 is 90, so this becomes 5 when you divide. So the inside is reduced to y plus 5, but you're not done. You've divided this by 18, so you have to indicate what you have done. So you're showing the factors. The factors are 18 and y plus 5. This 1y simply becomes y, and I can show or write that so it's more clear. So your two factors are 18 and y plus 5. So remember, what you divided by has to go on the outside of the parentheses, and whatever you ended up reducing on the numerators go here in the parentheses. So if we were to do the distributive property, we should get back the 18y plus 90, and that works. 18 times y is 18y, 18 times 5 is 90. Okay, so on this one it's a little more complicated. We have an exponent with the same base, which is nice, on each number. So in this situation, you take the one with the smallest exponent, which is the common factor between all of the x's, and you divide by the x squared. But we're not done. That's not the only thing you're going to divide each term by. You're going to also divide each term by a number that 24, 12, and 15 will divide by. When you have this kind of situation, 24 and 12 are even numbers, but 15 is not. So look at the odd number and think about the factors of 15. Factors of 15 are going to be 5 times 3, and then 15 times 1. And you have to think, well, what out of these factors will also fit into 12 and 24? Well, 5 is not going to go. 15 is not going to go. 1 is not very helpful, doesn't do much. So 3 is really the only one left. So you know you can divide each of these by 3, because 3 times 4 is 12, 3 times 8 is 24, 3 times 5 is 15. So we can divide each by the common factor of 3. So we decided in this divider by looking at the letters. So the greatest common factor between the letters is x squared. The greatest common factor between the numbers is 3. So now let's simplify. And when we simplify, we get 24 divided by 3, which is 8. Whoa. And we have x to the 6th over x to the squared, so you subtract 6 minus 2, which is x to the 4. It's plus, everything is plus on this one. It's kind of friendly in that way. So 3 into 12 is 4. The exponents can be subtracted, 4 minus 2, so that's x squared. And then the last term, the x squared over the x squared is 1, so it cancels. 3 divided by 15 is 5. So you have all of this. You can't combine anything because these are not like terms. But remember that you multiply this by whatever you divided here on the bottom. So that's 3x squared. And so now your factors are 3x squared times this, which is an 8, entire expression. And when you do the distributive property, you should get back this expression.